Great. Hello, everyone. Glad to see everyone back here at ClueCon. You guys all ready to mess up this industry? Ready? Well, we've been ready throughout the years of all the different steps that we've tried to do this through, and ClueCon's been with us all along. When we started our efforts in this field, we also started ClueCon, and we've been doing it every year. That's why we're at the 22nd year, so any baby born when ClueCon first started can drink now, if you want to believe that. So basically our timeline begins back in 2006, but the cool part is in red there at the top. Since 2023, everyone's been really excited about AI and what you can do with it. We've been excited about what goes under it before we even knew when it was going to happen. We all knew AI was coming at some point because people have been talking about it since the 50s, but we didn't know when exactly, but our thoughts were about infrastructure. The first thing we thought is that the future needs to run on software, and we have to be able to build the infrastructure below it, because without that, how are you going to get ahead? You're going to have to start from the bottom and build your way up from this massive hill. And we've been climbing up that hill a really long time, all of us together here. We've had many people in this room contribute to the overall industry of live telecom that runs on the internet, not just on phone lines. We're hoping there won't be phone lines for long. That might take just as long as faxing, but we're still going to keep praying for that. And we got it. So underneath is the platform that we've been working on for years, all of us here, figuring out how to take that telecom and move it to the cloud so that it can be programmable and useful to everyone and not just some arcane thing that lives in a weird box that nobody understands how to work. So we've been working on that, and one of the things we built, obviously, was FreeSWITCH, which is the media stack in this chart. That's still underway. There's a new patch in FreeSWITCH every 5 minutes. There's people working on it right now. I'll probably get a pull request while I'm standing here. This has been going on for a really long time, and one of the things that makes it possible is being sure to plan for how is that going to fit into the next step above it, right? So one of the reasons that FreeSWITCH is so popular is because we made it versatile, because we were thinking forward, what is going to need to be attached to this? Even in the early days, no one cared besides us in 2006 that we would have multiple sampling rates. Who needs that? The phone system is 8K. But we were sort of imagining a world where you would have more fancy different kinds of audio inputs and stuff going into live calls. And of course, when we got to the era of WebRTC, the next thing you know, we need 48 kilohertz and 16 kilohertz and both connected to each other. Luckily for us, we predicted that and did a lot of that work early so that we weren't stuck trying to figure it out when it happened. So one of the things that we're trying to do is when people use our technology, we want you to start from the top of this where the cool color scheme begins, because we don't want you to be building everything underneath over and over and over again. For one thing, you'll get different versions of it. Do you really want to have 17 renditions of a telecom stack when really their application, you're trying to sell a product, right? Anyone that's going to build something that makes money, the point is to figure out a problem to solve for a consumer or another enterprise and give them value so that they can buy it from you. And they won't even realize that you built your own telecom stack underneath, because that's not the cool part. It is for us because we are all obsessed with this kind of software stuff, but the people that on the other side of your product don't. And that's what we've tried to help with. So we welcome everyone that loves to dig into stuff and join our hackathons and code and come in ClueCon and talk about it, so we can help you start from somewhere where all that skill that you have is put into building your product and not reinventing the wheel. So this has been something that we actually used. The first FreeSWITCH website hardly had much. There was a caveman at the top, a little animated GIF of him like trying to like create a wheel with a hammer. And then we had all these different wheels, and we said like we're not trying to reinvent the wheel. That was like our original sort of mantra when we built it. And so what we used to do when we would add another technology is try to see if it already exists or not first, because we weren't keen on just reinventing it so that we could say we invented it. So if we saw another kind of technology, we would add a module for it, and we'd expose its all the things it had to offer into our platform. We think of our platform the same as we think about an operating system on a computer, that it's a bunch of tools underneath that you can add to with your own software. So that's why if you take something like the Linux kernel, I don't want to build my own kernel. It sounds fun, like I got a guy on my shoulder going, yeah, you could. Go make the Linux kernel. Make your own new kernel. You know, like, no, thank you. I'm going to stick with the one that's already there. A database, too. Like, I think I understand how databases work. Maybe I should write one first before I start my project. So, like, not really. There's plenty of those also, and lots of placeholders for something like that. Think up the stack with web servers, TLS. I wish TLS was different. To me, I wish it would start, you know, be so invisible that I didn't have to write 40,000 lines of code just to make the same exact socket app work the right way. But still, I'm going to stick with the one that already came. So we figured that our role in this whole stack is the soft switch, and we did that as well. We didn't want anyone to have to reinvent that again, since we're still doing it 20 years in. So when it comes to this new stuff, this is a repeat of what I've seen all the way back to the web hosting days. You know, when web hosting was new and the .com bubble was right around the corner, everybody was going crazy trying to build everything. So there's always a gold rush in the beginning. Like, there's a new thing. Let's all build it. I want to be the one that built it. If I build everything, maybe someone will give me a check for like $50 million, and then I'll be like rich and famous. So I'm going to like figure it all out and like get my pickaxes and go digging in the hills. So, but then you like slowly fail, right? And then there's only a couple that survive because it's just very painful, and how long can you work that way? And then that consolidation kicks in, right? So you have the ones that are actually like crazy enough to keep doing it no matter how painful and psychotic it feels. And then that's when the value starts to move up. So when you build these kind of things, you know, it comes down to just a few choices at the end. And we're seeing that starting already again. Everything that is AI powered, including the timeline, is accelerated because of AI. AI accelerates its own timeline. There's that famous book, like The Innovator's Dilemma, and it was written in the 90s, and it's still like totally true. And that one used like the speed of hard drives as an example because it accelerated so fast because everyone kept shrinking hard drives and making SD cards, and the AI is like 100 times faster. It is already just like time is moving like really, really fast. So we're in Act 1 of AI story, where there's the gold rush, and everybody wants to figure out what they can do. And they get all these ideas, like, let's take AI and like add it to stuff. You know, like AI powered everything. And of course, voice and telecom is one of those. And I'm guilty of that myself, because the second I saw that ChatGPT came out, and a month later they made an API out of it, that, you know, I realized it was important to integrate this with some of the things we do. The thing I wanted to fix for everyone else, as I started to meander through this, was I don't want you to have to solve an escape room to build your own product. Like, you run into all these things, especially the new era. So when ClueCon was new, more people were, say, like down in the basement. They had their compilers ready and lots of Linux servers, and they wanted to compile everything. And some of us here are those same people, and we can do that. But there's so many people now who are never even heard of any of this stuff that we're doing, but they still want it, right? There's like a resurgence. Like voice is supposed to be over with, you know? But then it's like, oh, I can hook AI up to it. Never mind, I think it's pretty cool. And then you end up stuck because you're coming to somewhere like a regular CPaaS who is just used to selling the same thing for 50 years, and you suddenly want to hook up your AI to it, and then you're wondering why it doesn't work, and it's slow, and like disconnects, and you're chasing after it, and then you fix it, and then someone convinces you to pump all the audio into your own service that you write yourself in Python, and then you don't remember how to connect microservices, and then all of a sudden one of them is dead, but you don't know which one. And then you're like, wait, I saw a hint over here, I should come back to this. Oh wait, except for 5 of your servers just crashed. Well, no, we have a meeting with the guy that wanted to buy it. Oh, it died right in the middle. You know, so you run into all this stuff, and the thing you wanted to do is sitting there rotting. The part of your product that you have the most control over, you don't even have any time to work on your product because you're stuck with all these crazy problems to solve. So we all love solving problems, and I think that even I've been thinking about this for years, like figuring out which one to attack first when you have 1,000 problems is one of the hardest things of all. And so what we try and help make everyone succeed with is to just focus on those things that they can control the most. These are some of the failure modes that everybody has been running into when we first started this, where you have like, you're trying to do a call transfer, it doesn't work. You're like wondering why there's like so much latency, but you can't remember, you know, like which one's which. Like it's only slow for an hour. Maybe you used one of those streaming APIs, and you don't know better that it's made out of TCP, which is not good for voice over IP. I think there's enough voice over IP people here to know that you shouldn't send your audio over TCP. But yet, like, the #1 way that you've been shown so far with WebRTC systems, they'll say here, it's a WebRTC gateway used as a streaming protocol over to OpenAI, except for it's like written as JSON with like encoded base64 encoded audio packets. That makes us all shudder here in VoIP land. We're like, why did we spend like 25 years making it so that the audio gets there instantly, and now you're sending it over reliable transport wrapped up inside of some kind of packet of JSON inside of a Python script? Like, that's no place for audio. So we saw all these problems, and we're like, why don't we just make sure that we absorb these into the mission we've already been on all this time, which is to make that telecom infrastructure as easy to work with as making websites. That's like one of our #1 goals as a technology. You know, in some of these models, you know, you build your own pipeline version and it doesn't work, and you think it's because the latency isn't great, because you have to do all these different things and it's going to take a lot of time, so we'll just get a speech-to-speech model instead. It solves all my problems, right? This is like literally mermaids lowering you to your death. This is the OpenAI and friends are making speech models from the sky because they want you to be like locked into using them only, and you have no more choices. As soon as you use a speech model, you're stuck with 1 or 2 voices if you're lucky. And I can tell you, we support it at SignalWire, but we don't release it publicly. It's only in a beta because we don't even want to sell it, because when you use it, the only thing it does really good is talk. It doesn't perform. And like, what you need the most is to execute the tools at the right time. It's the #1 thing you need from AI. And the voice models haven't figured that out yet because it's like an afterthought for them. So they're still working on it. Maybe someday it'll work and it'll be really fast. But it won't solve your immediate problems, and it doesn't give you any flexibility to do more advanced things. Because we have an entire philosophy around avoiding being at the mercy of AI, which is why it was fun to see everyone building stuff yesterday, all these voice AI bots, because that's really kind of where it starts. And it's easy to imagine the end because it's not that much of a stretch, you know, because, well, AI generates text, and text-to-speech can talk, and I already have something that can understand my speech. But there's so much more to it if you're trying to make something that's put in front of a complete stranger, like someone's grandma, calling in to ask a question. And then if the AI behaves the way it does with, like, say, our coding agents, the only solution there is to yell at it all the time. You tell it it did it wrong, and you spend like hours arguing with your own AI agent. Like, you can't, the people calling to check their status of their account aren't going to know better and tell when it's lying or not, and all those kind of things. We call that prompt and pray. And this is what we've been seeing, and it's something we want to end because it only took us, say, 3 days to reach the status of being able to create a prompt and pray agent. When we first started building, it was easy. I wrote a prototype. It was just funny. You have funny conversations with the AI bot because you gave it a little prompt on what its role was, and you talked to it. And you want it to actually do stuff. It's like an entirely different story, because the more complicated you get, the harder it is to just give the instruction set. And if you had something you really care about, like the airplane pilot about to fly the plane you're getting in, and he never did it before, would you just give him a piece of paper with all the rules about how to make sure that you fly the airplane correctly? If you imagine that, like anything that you've never done before, and like you might as well think of the AI the same way. Like, it doesn't know anything until you tell it. So you can't just give it 1,000 exceptions, because those all cause migraine headaches in the thing. AI models get like headaches because they get torn. When you tell it to do two things at once, it gets really, it's funny actually, if you use an LLM, try it. Give it instructions that contradict and turn the thinking on, and watch it go on for like 5 paragraphs trying to decide what to do when it gets into a conflict. So one of the things that we try and do to stop this is to be able to build something that puts a harness around it. And that's easy to say, because as soon as someone hears that, that's like, that's a good line, I'm going to use that. And it's true, building harnesses around it is important, because we've learned that. Because if anyone here, how many use some kind of coding agent right now? Let me see hands. I'm sure you've learned that those coding agents are on a leash, right? Especially like, I think Claude is the best at doing this. We learned that when they had their software leak, and everyone was peeking at it. And a couple people clean roomed it. There's like, I think someone made one in Rust that's like a faithful reproduction of whatever they saw. And what they learned was that it was almost all instructions. I found that super validating, because I was saying that for a pretty long time as we were working on this technology ourselves, because that is where all the control comes from. Because otherwise, you just let it roll. What it really wants to do is just spam tokens for the rest of the time. And you don't have something, like, you wouldn't even know. You're asking it to help you solve a problem. Like, the guardrails inside are probably cutting it off and making it start again like 7 or 8 times from one question you asked it, to make sure it comes out right, and the things it does to try and solve the problems. So in the voice world, we're running into this kind of problems where all this stuff below is actually really hard and distracting. So you're trying to show something on the outside, and it's like pretty cool, but you have no idea like all the things that are happening underneath that have to scale. That's the most important thing. So if you're building a cool demo, you have to make sure that you have to scale it. And some people can put that off, like, I'll do that later. Everyone will love my product so much, they'll give me money, and then I'll figure out how to build infrastructure. I think that what some of the big guys are doing right now, who've just started to take off in the voice AI world, because they are hopeful. And I've seen the same thing happen to many others that don't exist that much anymore now. The telecom providers of the past, they're all kind of out of touch now. And so what we want to figure out how to do is get all of us to figure out how to focus on products and not starting from scratch every time. This is an internal dilemma. So we're an engineering-heavy company, and we have to do this all the time to ourselves. Like, does it sound fun? Yes, but do not fall into the trap of trying to go and start the entire thing from the bottom, because that takes that's like a madman's path, and I can tell you that's why I did it. I'm a madman back in 2006, but there wasn't really that many choices back then, you know. So we were trying to figure out, like, if we go through this jungle, can we leave a paved road behind us? And I think we did a good job in the beginning because we have an entire list of logos that FreeSWITCH is powering that are all pretty well known, right? You have all these different companies that are very successful in the, say, like what I call the CPAST. That was the first round of you know, exposing telecom to people in a simpler way. So you have your REST API to send text messages, and you have kind of basic voice menus, and you just make it transactional, and you stay out of the rest of the business because you don't want to figure that problem out because it's too hard. And what we like to do is eat problems so that that green box is everything. That's where it all matters. Like, you could make something worse, and it doesn't matter. You know, go back and study the history of like Apple versus Mac over the years. You know, Apple and Mac versus Windows and PCs, and even the ones that were kind of Mac's superior and amazing in 100 ways back then, and the PC kind of sucked, and you had to like build it yourself and couldn't find the right hardware and stuff. But yet it was more popular because of the way they talked about it and where they showed you to start from. So we want you to take that weekend or your day at the Coder Games and build on top of stuff that all of us have put a lot of work into, right? Like, you're going to hear from all these different people who have built the underlying plumbing that makes it possible to build things quickly throughout this conference. And you should give them all a really big hand when you see them, because they've also spent at least multiple decades working on some of these pieces of this problem. And something that we all are used to as engineers is, at least when we make a mistake, it's like a mistake we built wrong, and it makes a mistake every time, and we can figure it out. You know, you might have race conditions sometimes, you know, when we didn't mean it. Like in FreeSWITCH, we thought everything was great until, you know, multiple cores came out, right? We started building it on a 2-core machine, everything was great, and then we got like a 4 and an 8. At one point, we're at 192 cores. You definitely have gotten rid of every race condition you can think of. But it's all procedural and structured. But we don't just hope that it works, right? Like, we don't just kind of ask the code to please don't segfault, and please don't deadlock, and please don't have race conditions. We look at the problem and we fix it with our engineering skills. And that's what we want people to be able to do when they're building AI, because it isn't really about the mechanism that makes it able to talk. It's about making sure that once you have that mechanism, how do you keep that mechanism from being useless? Having to, the only feature is to offer, you know, you ask it questions and then it doesn't know how to do anything. It gives you one choice, which is, would you like to hear more about our new product? Or whatever you might want to teach it to say. Do you want it to actually sell a product to other people where it solves a problem for them without them needing to realize that they don't have to be tricked into not knowing it's AI, but they shouldn't be required to like yell at it and correct it so that it works right, because that's where it stops. You can't trust regular people to even realize that. If I realized there's AI, I would definitely mess with it. I do it all the time. I could go on to DoorDash has AI help, and if you mess with it long enough, you can get it to start speaking like Dr. Seuss and fun things like that. But you know, regular people don't have as much patience. And this is something that the philosophy that we're trying to teach is to make it so that when you build agents, they're being driven by software in as close to as a predictable way as you can get. And not to just tell it, please work. Don't do that. Make sure as soon as you say that, you heard that yesterday, the famous pink elephant. As soon as you tell it not to do something, it does it 4 times. So we can make kind of quick wins with prompts, but the prompts have to be sparingly used for separate steps. And anything that can possibly be still solved by a computer program, then it should be still. And that's why we make this stuff. We want you to use your programming skills to keep that AI in line so that it's reduced to having no way to make mistakes. So we don't just hand the model everything. It's fun. It's actually really insane to take something like Claude and you give them a problem and a bunch of stuff like, here's my email and access to this website controller or whatever, and he goes and figures out how to fix it for you. That's like a different model of solving problems that are meant for people building stuff where they're the boss of the AI, right? Like if you build AI that way, you give it all the tools it needs, it'll like pick which one it needs at the right time and it'll go solve your problem for you. Usually you still have to direct it to what to do, but it's way more expensive, right? We all probably spent like half our life savings on Claude already. But that's why that's the frontline model, and it's slow and thoughtful, and sometimes you have to sit there and I don't know how many of you that said you use AI use Claude and want to like punch the table when you like it says still thinking over and over and over and over again when it's getting whether there's an outage or something. But you have this other side of the coin where when you're trying to build something that can autonomously run, and that's the important part, because almost all voice AI solutions are going to have to run autonomously and still solve a problem for a random caller. And you take away as many of the tools as you can, and you figure out when they're okay and when they're not, and you give them concepts that they can bite-size understand instead of trying to tell them the entire story at once. So you spoon-feed it what its newest problem is on the stack. And like, for instance, if it has a lot of problems it can solve, you can use your code to switch the story so that it focuses on the problem. So you're actually helping give it a half mechanical brain and not just be like random inference. Because if you're going to say, I can help you find a movie or a restaurant, and you just let it have all the tools for both, you never know it's going to like pick the wrong one and stuff. If you give it a tool, it'll run it for sure. So you got to make sure that's in the context of when. And if you think of it like a play, which is how most of these AI models are trained, they're in an actor model where they think that they're performing a role. The best part that you can do as a programmer is control the scenery in this set. And which scene are we in right now? And don't tell it the entire play and try and have it execute the whole thing in one go, because it doesn't have the capacity to do that. But you can tell it, like, scene one, the introduction, your role is to tell everyone hello. And then you can control that. And then you maybe give it one little choice, like, what does give the people a couple choices, and they pick one. You wipe the stage, set up the new one, put the new actor in place, and you can edit things. And your code is keeping it in track. And the reason that you want to do that is so that you can force the outcomes as close to every time as possible. If the outcomes differ in how it talks, that's not a big deal. And I'm sure everyone here has built a web page before with an HTML form. You know, that was the first way we made cool stuff, right? Like, wow, I can make a web page and there's a form and I fill out the answers and I hit submit and then like another form shows up. If you think about your AI that way, the actual model can become the form asking the questions, and that's its job, not to solve everything for you, because that's what you guys are for. You still have to solve making sure that it does everything right. You can't just hope. And so we have this kind of philosophy then where we can run like 100 of an agent, make it do the same outcomes, and see how well it does at it. Because another trap, and I fell into this myself, was before I kind of came up with this philosophy of how to design these things, it would be like, okay, I tried it and it worked. Okay, maybe it's luck. I'm going to try it 3 more times. It worked. The next day it's wrong every time because just whatever random determinism kicked in. Maybe the server I was on was caching the results towards the answer that I wanted, and the next day it's completely wrong, and then you're beating your head. You know, we've all beat ourselves up before, like it was working yesterday. It's one of the tropes of an engineer. But it's like amplified if you're just trusting AI to do stuff. It literally will just go away. Something that worked perfectly stops working. So you have to try it like 100 times sometimes to figure it out. And even then, there still might be one out of those 100 where it kind of just freaks out and does something stupid. So we try and make things organized and built in code. And the main problem we're trying to solve there when we built it in code was we don't want to put the burden on the programmer to deal with the media, because that's something that we've spent decades building. If you build the media somewhere else and then move the signaling to where it's a different place, that's how we designed telecom in the first place. I'm sure a lot of us here will remember and still even probably mess with these things where you have like SS7 switches that are driving 1 million media servers. You know, we do that with SIP now too. We put a SIP proxy in front of a bunch of media engines, and the SIP is the part that's kind of like making sure everything goes where it's supposed to, and the media engine is just moving the stuff along and making sure that the call happens and the audio works. And we split those on purpose because of 2 different problems, and they don't require the same kind of build out, because the media server requires like a lot of hardware and a lot of specially chosen network settings to optimize to have 1,000 streams of audio go through the same server and not have any of them get stuck. The signaling is a whole different story, right? And we think of the telling your AI what to do as the signaling for your product. So we wanted to let you control that as much as possible, because then you can do anything. You can tell it to call you, tell it to stay there, go in the conference, put 2 people's bridge together, switch it back to being AI again, and let that AI live in that media stack, and then get everything you ever wanted to know about it being sent to you over a really quick interface, so that you can just build your stuff in code and then it executes instructions. So one thing I wanted to talk about here is that we started with voice on purpose because I thought that was a harder problem. I saw AI coming, and I bet everyone is going to make a chatbot tomorrow. They're going to go and take ChatGPT API and like connect it to your favorite CPaaS, and wow, I can text. Well, sadly, you can't, because the industry is going south and they're taking away the ability to do anything over SMS these days. But you can still do it from like applets and stuff. And we got to the point where we built out an engine, the ones that everybody was using in the demos yesterday, and we wanted to make it work with chat as well. But we didn't want to just go build another one. We followed our own principles, and we built the implementation of the chat that would match the same exact the code that you wrote to do your voice. So if you say build a voice app on our SDK and you use it so that you can have it go through a bunch of steps and execute things and give it tools at the right time and everything we've been talking about, and you want to do that over chat instead, then you can. We just put this generally available last Friday, so anyone that's playing around with SignalWire still, trying to win dangerous demos or any other stuff, we have a brand new chat API where you can do voice or chat to do the same thing. So that's live now. So I'm just going to do the classic demo I always do during ClueCon. As soon as my computer stops being overloaded. So I built a demo that lets you switch back and forth between chatting and voice. So I'm going to start with chat. And I'll say, I'm getting this classic thing where Maybe I won't because my keyboard doesn't work. Our decimator is decimating my keyboard. Do we still have that roving camera? The camera I used yesterday when we were doing the, okay.
That's great.
One second here. We lost my. All right, I think actually that was the issue. Blink. Yeah, you need a keyboard in order to type things. Let's see if we get it back now. Typing, yay. I think you can go back to the other one now. I figure. I think my keyboard just froze on my computer from all the fun. Okay, yeah. So I can ask this chat version of Sigmund the question, like, what's the weather in Orlando? And he'll look it up. He's very helpful. And then say, I'm sick of this. I want to talk to you, Sigmund. I can convert the widget to voice.
Hey there, I'm Sigmund, your friendly demo. We were just chatting about the weather in Orlando, but now that we're on a voice call, what else can bot from SignalWire I help you with today? Are you exploring SignalWire for a project or just checking things out?
Can you tell me the weather in Chicago?
Looking it up. The current weather in Chicago is misty, with a temperature of about 76 degrees Fahrenheit. There's a north-northwest wind blowing at nearly 12 miles per hour.
Okay, now I think I want to chat again because he's obnoxious today. Okay, and then just right back to chat. And then finally, that's the end, but let's go mess stuff up. That's what I was saying, right? Build stuff. Follow principles that make you successful, and this industry is not just going to be wiped out by like one or two companies that think they're going to sweep everything. You guys are here to build stuff. Keep going, and thank you, everyone.
Thank you, Tony. Now, we do have time for just one or two questions, and Jason is there with the roving mic. So if anybody's got a question, raise your hand, and Jason will run along with a microphone for you. There's one, just there, Jason. Jason? Oh, okay. Well, this gent was first, and then there's one over there, I think. Yeah, there we go.
You
ahead,
said
sir.
not to use TCP.
One of us is too
That's
close
me,
to each
I
other.
think.
It's probably me. Let me go away from you.
You said not to use TCP for video communication. I missed the context, so what do you use instead of TCP?
Don't use TCP to send your live voice over IP of any protocol, not audio or video, because TCP is a reliable transport, and that's a good thing when you're streaming Netflix, because you'll make sure you get it all, and the Netflix is smart enough to buffer, and there's not a real person on the other side that needs to hear each other immediately. So what happens is, in TCP, say there's a storm in the internet somewhere in the middle, it will get stuck, and its job is to reliably send you all of the media. So it will get stuck there, and then you'll have giant, like 5-second gaps. And especially when you're working with some of these technologies where it's like you're building your stack from 7 providers and you're connecting to them all separately, and one of them is sending you that kind of media stream over TCP, then you run into these problems where, like, let's say you're trying to implement something to cut the audio off, but it actually it got stuck because the internet's messed up right now. For your message and the audio are both stuck, and one of them comes free finally, and it didn't even say what you wanted to cut off yet because it's stuck, or the other way around, like you heard it all too late, and then the message gets there, and you end up having, lots of problems. We made voice over IP work on mostly UDP, and there's like TCP is the last resort when there's the only possible way, and almost nobody still does it. You might do it with turn if you're behind 17 NATs hiding in some like corporate office that won't let anything through, because then you can masquerade like you're like a web page. But for the most part, it's a really bad practice because you'll miss out on the real time. Because the secret to latency is to make sure the audio gets there as fast as possible. And that's just one of the ways that it doesn't get there fast. And that needs to be solved, otherwise everyone that builds on that model will end up suffering through those problems. We actually have that streaming protocol implemented for people that want to use it, but I don't like it. I made it possible. I let us have it because I think it's compatible with everyone else, and if you want to migrate and stuff, it's cool, but you should try and avoid it because it's really the antithesis of all the work that everyone did to make voice over IP real time.
This seems like the right kind of time for me to tell you my joke about UDP, but I'm not sure you'd get it.
No.
Jason, I think there was another question somewhere over there. I thought I saw a raised hand.
If not, I have one myself if no one else has one. I can't help but think that this would tackle the main crux of the issue with like all of the your series and the various different tools that all the major devices are using. Because when you ask Siri to go and do something, Siri has to like follow some arbitrary path that has been built over 20 years or so. I wonder if you could like expound if Siri were built over like SignalWire, would it be able to access all the different services necessary to be able to actually achieve the things that thing?
So you take like your Siris and Alexa kind of things, and they're kind of lucky because they run in specific hardware. Like they have your whole phone at their mercy, or Amazon has these Echo devices and stuff. There's an unfair advantage there because it has a bunch of hardware to figure out everything, but it is limited to being like, it's an endpoint, really, right? It's not a communications channel. So the difference would be if you wanted to have like Siri or Alexa answer your support calls too, that someone just dialed 555 help me, and you wanted to have that same thing answer the phone.
Yeah.
Now you can actually build applications to do that, or start from your website. So you wanted to press a button and get right to that automated help agent that behaved in a similar way. So anybody that wanted to go to that could make those experiences. And if you wanted to start from those devices, you could also do that because you're piping the experience over to another place. Yeah. And that's kind of the advantage of building telecom that has embedded AI stuff, because then you can do things that scale from the cloud without only serving that one person that has the device with them.
Right. That's exactly what I was thinking. Thank you.
Thank you, Jason.
Oh, my.
Look,
Questions?
we've got just 2 more questions, then we must carry on. I think there's 3 actually, isn't there?
Yes, there are.
Oh, boy.
You're saying that don't use real time, but you're still having a latency issue by now having to text-to-speech and speech-to-text. I mean, so you can't get away from it. The reason that real time works really well with OpenAI is they have all the hardware there to do it. So they turn around quickly, but it doesn't work, as you said, right?
That's the trade-off, because they focused on trying to get the media coming as fast as possible, but not the rest of the problem. And maybe that'll get fixed someday. But by the time it does, I predict you'll probably have your own copy of it running somewhere.
Because that's a complaint now with the customers. They're saying, sorry, it sounds robotic, or it doesn't sound really well, or there's too much latency. if you do the pipeline, right? So there's no, so you're kind of forced to go to real time because they are able to do it quickly. And now you're fighting as you said, works for that 1 hour a day. You actually have, when it doesn't work on their side, you're stuck and you can't do anything about it.
My solution was to make the pipeline as fast as the speech models. I used every inch of my engineering skills to focus on it. So, but yes, if you try and do it with a bunch of Python scripts and stuff, it's going to be a sad day.
Okay, thank you, Ninad. Here's the next question, then we'll have one more here. Go ahead.
So just dumbing it down for me, Anthony, just a soundbite. So what's the biggest thing that's holding up AI agents in production? You have all these companies investing in it, but I feel like there's not that many that are actually in production and actually delivering good results today.
Having it be reliable enough to trust to do anything. Because we have one of the main ways that we solve the problem today, if we're not, the classic solution is take that feature out. Oh, it keeps doing the same thing wrong. It won't, every time it tries to, like the funny Taco Bell, 18,000 waters, and it said, yes, let's take away that. Never mind, we don't have AI ordering anymore. Or you have a thing that answers the phone and it's supposed to help you with your account and has 5 features. And as soon as that feature keeps going off the rails, you have to remove it until you're down to the only thing it can say is, have you read our FAQ? Try looking on our website. And why did you waste all your time building an AI agent that just answers the phone and plays the recording, right? You could have just, you can use SignalWire to build that. Just make that recording as a WAV file and stick it on an extension and point a number at it, and then it'll just tell it. That's what we already did. That's why we built IVRs for 20 years before this. So, and everything that IVRs make everyone want to beat their head in, solved as well, because we have to overcome years of IVR sucking so bad that the solution was to go back to people again. And to me, replacing IVRs with people is similar to forcing people to build the pyramids by dragging rocks up a hill with a rope. We do not want to give people a role to answer the phone and look at a piece of paper and say answers. And that's the thing. Being able to trust it to actually do the job that you gave it. And if you're trying to replace jobs with AI, you don't have to be that, a robot is going to be sitting in your desk instead of you kind of mentality. It's more about jobs that are too hard to fill with people, because you can't have 10,000 people in case you get a surge of calls at your call center. You only want to have on-demand ones be able to answer the phone and get rid of the ones that are easy, and then you can route the other ones to everybody else.
Okay, if you want to carry on that conversation, of course, you can go to the speaker lounge in the break. We've got one more question before we hand over to Kishore. No, it's a guy behind you.
Hi, how's it going? My name is Masood. I'm at a company called Tin Can. We make a Wi-Fi phone for kids, no screen, and the parents approve the contacts. So I'm pretty new at the company, and I'm just learning about these telephone systems. So my question is basically about integrating FreeSWITCH and Comet Ilio and these types of technologies. I think there's a sense that it can take a long time to integrate and get something that's reliable, that works, that has all the bells and whistles that you need specifically for a particular use case. So I'm wondering if you agree with the statement that one of the reasons for that is that these open source projects are pretty unopinionated. And that means you have to make a whole bunch of decisions as you're building any particular solution, and that can be why it can take so long. Just wondering, do you agree or disagree with the premise?
I think so. Being opinionated is my favorite part about starting SignalWire, because I wrote FreeSWITCH in 2006, and I wanted to make sure everyone was happy. And I also come from a Perl background. I used to write code in Perl, and Perl is makes you everything is possible any way you want kind of mentality, and you can write the code however you please, and it depends on your style and stuff. And I am a Unix enthusiast since birth. My first computer was a Unix terminal, literally. So I always think of giving people options and letting things flow into each other. When I made FreeSWITCH, I made sure that was all possible, but I couldn't be opinionated because everybody wanted stuff that was opposite. One person's features, another person's bugs, so we'd have to make parameters and more parameters and handle it, detect a certain situation. So now we have SignalWire, where it's fun because we get to pick exactly what we want to have work the best way. But yeah, that is having a lot of those choices. It's just like when you're building stuff from scratch, it could be fun, but it also is pretty hard because you start getting all these, which way should I do it? There's 30 different ways. Which protocol should we pick? How should we arrange the servers? Which kind of, like, should we do a star configuration? Should we run the media in the kernel? Should we put it on multiple servers? What do we have? Redundancy and backup? And so there are a lot of questions start showing up. That's also why we built SignalWire, because we were sick of doing that. Because we used to do a consulting for people building all their own FreeSWITCH and before we started it, and it was always repeating all that stuff. And everybody would run into every one of the same roadblocks, and we still think that if you know how to do it, then you ought to. But if you don't need to, you don't have to. So.
Okay, thank you very much. ClueCon, thank you to Tony.